Okay, so this is the last problem I'm going to do in this particular set. Reminder, 1324, page 600. Actually, I think it goes to page 601 if you're using the new textbook, and the old one, maybe it's 599 or so. And yeah, so this is from that particular problem set. This is problem D. So I'm going to jump right in. First things first, the elements or the degrees of unsaturation. So we have 4 carbons multiplied by 2, that's 8, plus 2, that's 10. Subtract your number of hydrogens, that leaves 2, and then you divide that by 2, giving you 1 degree of unsaturation. So I'm just gonna put that over here just so we have enough space. So we want to keep an eye out for that 1 degree of unsaturation. And yeah, let's start tackling this problem. So the first thing, when I look at this, the first thing that kind of jumps out at me is right here in this region between 5 and 6, we have 3 different hydrogen peaks. The 5 to 6 region is sort of, I guess, a telltale sign that you're looking at some vinyl hydrogens. And if you look, we have 1 hydrogen, 2, 3. So we have 3 hydrogens, and if we're looking at sort of a vinyl group, I'm going to draw that up here. We have the double bond. 3 hydrogens actually makes this pretty easy for us, because we don't have to deal with coupling constants, figuring out, oh, are they cis to each other or trans to each other or whatever, because if we have 3, then that just leaves these, and then there's just 1 coming off. And this takes care of our degree of unsaturation. So I'm feeling pretty good because we just knocked all of this off and we have it taken care of, accounted for in this group. So the next part, I think, is the easy one to look at, is this guy all the way at the end. So we're looking at 3 hydrogens, and it's being split into a doublet, which I'm saying means it's being split by a single hydrogen. So I'm going to just draw out what this group could look like. So there's your methyl group. It's being split by a single hydrogen adjacent to it. So this guy's going off into 2 different regions, isolated, not next to any other hydrogens. So that takes care of this peak, and it also takes care of one of these. I'm going to go ahead and say it's this one, because if you count, it looks like it's a multuplet, so that would make sense. This hydrogen is being split by these carbons, so go ahead and pair those up. So we have these taken care of. Now this hydrogen right here. Well, there's 2 things I'm looking at. One, you can't always just do each part one at a time. You have to integrate your parts. Something that sort of jumps out to me about this hydrogen is it shifted up around 4. That's usually going to be a sign that it's attached to some sort of electronegative atom. Furthermore, let me just double check, make sure. Yeah, so furthermore, we have this hydrogen right here. Says that it's isolated, but if we look at what we have so far, 1, 2, 3, 4, we've accounted for all of the carbons. Oh, we haven't accounted for an oxygen yet. So that means that this last one must be a hydroxyl. And if you remember, these exchangeable protons, these hydroxyl protons, they're not always split by their adjacent hydrogens. Now, since we're pretty much have this thing solved already, there's not many places we could put that oxygen. If we attach it to here, that would be an eno. That wouldn't make sense. It doesn't leave. It leaves us without anything over here. So I'm going to go ahead and attach this hydroxyl group right here. From here, I mean, it all comes together that this must attach to here since we've solved all the pieces together. I don't know if a bond makes that shape in real life. I'll go ahead and redraw it, but let me account for it real quick. So we have 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. So that accounts for them. The single oxygen, have that covered. 4 carbons, like I said, already have that covered. Let me Let me draw that again to make it look prettier. But I'd say that this one makes sense as well. So that's your CH group, and then over here I'm going to say the CH3, and over here, actually to make it make sense, your hydroxyl group. And that seems to account for everything. So these are all the problems that I'm going to do. Keep practicing. After a while, when you're doing these a lot, you start to see patterns, everything starts making sense. You get a lot better at the sort of method of solving these sort of problems and being able to not only look at an individual set of peaks and say, oh, those look like vinyl hydrogens, but bringing information together and saying, oh, well, I can account for this sort of, this downshift over here because of this group that it looks like over here. You start bringing things together more. And yeah, NMR problems can be a lot of fun. So keep practicing, and we'll do some more difficult, more advanced ones in class this coming week.